So this is a continuation of the previous video where we went over these problems here, A through D. We used a couple of different tests there. So let's go down to these two new ones. I'll just remind you, I want to determine if it converges or diverges, show complete work. Sometimes there's more than one test that will work. So let's go ahead with this one. So E. E is one that there's kind of like a quick way to do it, and then way that also works that is also just as good but takes a little bit more time. I'm going to do the quick way first. This one diverges by nth term. And the reason why I see that, and I look at that for this one, is I have a 3 to the n plus 6. The plus 6 doesn't matter too much. And then a 5 times n in the bottom. Well, 3 to the n is exponential, and this is linear. The exponential is going to grow way faster. So that's what I recognize when I see this. So what I write is that the limit as n goes to infinity of, and I just write the terms. The terms here are just what's there without the sigma. 3 to the n plus 6 over 5 times n. Well, that actually is equal to infinity. That's definitely not equal to 0. So I need to remember if the limit of the terms is non-zero, which is what I wrote here, then it diverges by the nth term test. So I'll write diverges by nth term. So that might not jump out to you right away, but our favorite test, the ratio test, also works for this one. So I'm going to set that up, and you can see how that works as well. I can write the limit as n goes to infinity. So I'll do the ratio test in purple instead of in green. Of absolute value, a sub n plus 1 over a sub n. That's equal to, all right, the limit as n goes to infinity, absolute value. I get 3 to the n plus 1 plus 6 over 5 times n plus 1 divided by 3 to the n plus 6 over 5 times n. And then I simplify that, which gives me the limit as n goes to infinity of the absolute value, 3 to the n plus 1 plus 6 over 5 times n plus 1. Copy dot flip, 5n over 3 to the n plus, sorry, I'm not going to put the plus up there, plus 6. I'm going to rewrite this as the limit as n goes to infinity of the absolute value of 3 to the n plus 1 plus 6 over 3 to the n plus 6 times 5 times n, or 5 times n plus 1. Now, this one, this limit. So I reordered it so it'd be easier to see what interacts with what. Well, this limit here, the 6's don't matter. And then if you think about it, if the 6's don't matter, the 3 to the n is going to divide into the 3 to the n plus 1, the same way that some of these things interacted like this piece right here in the earlier problem. So what's that wind up giving me? That gives me that this is equal to 3 times, that's this whole fraction right here goes to 3. I'll write 3 over 1 if that helps you. And then times, if I let this go to infinity, the n go to infinity here, well, the 5's just cancel each other out. The plus 1 doesn't matter, and it just gives me 1, which is 3. And then I write, well, that's greater than 1, unlike the previous ratio test that we did that was less than 1. And what's that tell me when I get a ratio greater than 1? That, whoops, not equals. Therefore, it diverges by the ratio test. Hopefully you are good with either the green or the purple, or maybe even both. That'd be great. So let's move on to F. All right, let's zoom in a little bit in on F here. So F has sigma n equals 1 to infinity of n over the root of n to the 6 plus 1. So whenever we have a bunch of polynomials like that, and what I mean by polynomials is this is 3 to the n. That's not a polynomial. A polynomial has n 2 powers, right? So here I've got n, which is to the first power, polynomial, over root n to the 6 plus 1, also polynomial. Anytime I got one of these, we're either looking to do p-series, or if it's got these extra pieces here, we want to go and do limit comparison test, LCT. So when I do LCT, I do some scratch work. Let's zoom out a little bit. Where I just write the terms over root n to the 6 plus 1. Well, I'm just going to say, well, when n goes to infinity, that doesn't matter. So I get n over root n to the 6th. And then I'm going to simplify this out. This is n over, all right, root n to the 6 gives me n cubed. And then I simplify that down and get 1 over n squared. So what I'm going to do is do LCT with sigma n equals 1 to infinity of 1 over n squared, comma, all right, what's 1 over n squared do? Well, it's a p-series, which converges by p-series. And then you might write in parentheses p equals 2 greater than 1. Okay, so from here, I just need to calculate another limit. I write L equals limit as n goes to infinity, absolute value. I'm going to take this one right here, n over root n to the 6 plus 1. And then I'm going to divide by 1 over n squared. And then that is equal to the limit as n goes to infinity, absolute value, copy dot flip, n over root n to the 6 plus 1 times n squared over 1 equals, now I'm going to combine like terms in the top. This is the limit as n goes to infinity, absolute value. I have n cubed, cubed over root n to the 6 plus 1. Now, you might just say, oh, I know this limit's 1. I'm going to show a little bit of work here. This is the same as the limit as n goes to infinity of the absolute value. When I'm letting this go to infinity, this plus 1 doesn't really matter. So I have n cubed over root n to the 6, which is equal to the limit as n goes to infinity of, what do I get? N cubed. When I screw it n to the 6, I get n cubed over n cubed, which is equal to 1. And then from there, I just need to get a number here that is not 1, or say that is not 0 and that is not infinity. So I just follow this up with saying, therefore, converges by LCT. Oh, sorry. I'm going to back that up a little bit. I can say, therefore, converges by LCT, but I want to remind you that, therefore, this series here does the same thing that this series here does. Since my 1 over n squared converged by p-series, we know that this one also converges by p-series. All right, that's it. Hopefully these help. See ya.